Okay, class. So notice that on the previous video, we discussed the definition of limits. So let's review quickly what they are before I apply to a problem here. Okay? So here's the definition of a limit, or a continuous function, sorry. Okay? A function is said to be continuous if it meets those three conditions all at once. The limit has to exist as you approaches the constant, wherever that constant is on your x-axis, right? From the left and the right, it has to have the same limit. When you plug in the constant to your function, it has to give you a value, and therefore the limit and that value has to also exist. And those are the three conditions to consider it a continuous. And so I'm going to run the test mathematically on a problem so you guys can see exactly what I'm talking about. Okay? So here's the example here. Here we go. All right. So notice here it tells me, here's the piecewise function. It says if a function is either not equal to 2, in other words, less than 2 or greater than 2, then it's going to behave like this. If it's exactly at 2, it's going to give you an output of 5. In other words, if I plug in my function 2 in here, I will get 5. Anywhere else, I will get this equation, right? So the first thing I'm going to do is I'm going to write down the three conditions I can test. So the limit x approaches c of f of x has to exist. That's condition 1. Number 2, f of c has to also exist. And then finally, condition 3, the limit as x approaches c has to equal to f of c in order for it to be continuous. Okay, so if I look at here, can you see here that if I want to check 2 minus and 2 plus, I have to use the same function, right? So let's check 2 minus and 2 plus. So I'm going to use the same function here. And so I'm going to say, okay, I want to know the limit as I approaches 2 minus and 2 plus. Okay. If I plug in 2 in here, it will be 2 squared, which is 4. 4 minus 4 is 0. So it's undefined. Right? So I know it's undefined, and so I got to simplify it out. And so you can see here, when I simplified, x to the 4th minus 16 is actually a difference of 2 perfects squared. Yeah? And so by factoring a difference of 2 squared, you'll get x squared minus 4, x squared plus 4, divided by x squared minus 4, and therefore x squared minus 4 will reduce. So this is called a removable discontinuity because you can reduce them after you simplify. Okay? In other words, I'll have a gap in there somewhere on my graph, particularly around 2. There'll be a gap. Okay? There'll be a little tiny empty space that's considered a removable case. Okay? It looks like this one. You're not sure. Here, see that? We can reduce, so there's a gap at -2. There's a gap there, gap there. Okay? Now, you can see that by taking the limit, I would then get 2 squared. So plug in 2. Can't reduce anymore, so I'm going to plug in 2. 2 squared is 4. 4 plus 4 is 8. And so the limit as x approaches c from the left and the right will be about 8. So it'll be approaching 8. Okay? So condition 1, check, because it exists. Let's check condition 2. Does the value at 2 exist? Yes, it does. When I plug in 2 to my function, plug in 2 at 2, my function spit out 5. And so, yes, it exists. The reason why this is not a continuous function, because look, the limit does not equals the value at 2. See? 5 and 8. Okay? 8 does not equal to 5. And therefore, it does not satisfy condition 3. And that is not a continuous function. Okay? Let's look at example 2 there. Take a look at here. Here's example 2. Okay? Again, the 3 condition. How do you know if this function is continuous? You gotta look at the 3 condition. So here's are the 3 condition. Okay? Condition 1. the limit as x approaches c, f of x of my function has to exist. Condition 2, the value as c has to exist. And then condition 3, okay, the limit as x approaches c has to equal to f of c for it to be continuous. So let's check. Okay, I need to check the limit. So in order to check the limit, I have to check my constant here is 1 because I want to see if it's continuous at 1. So my constant is 1. So I gotta check 1 from the left. Well, 1 from the left is less than 0, right before 1. So it's kind of like 1 minus 0.0001. So it's kind of like 0.9999, just right before 1. So that's less than 1, so it must be here. See the yellow equation? So that means it's going to be x squared. So I'm going to plug in roughly about 1 into x. X squared will give me 1. So that limit is roughly 1. Okay? Now, from the right, just right before 1, so that's kind of like 1 plus 0.0001. And so that's like 1.0001, doesn't it? So that's like the pink equation because that's to the right of 1, greater than 1. So this is C plus, this is C minus. So that's C plus, that means I'm going to plug in roughly about 1 here, and so I'm going to get 2 times 1 minus 1, which is roughly 1. So you can see the limit from the left equals the limit from the right, so the limit of x approaches 1 equals 1 exists. So condition 1 satisfied. Take a look at condition 2. Does the value of c exist? So if I plug in 1 into f, does that equal something? Well, take a look at here. If I plug in 1 here, see that? Into my function, does it equal something? Yes, it does. It equals 1 also. You see that? So, condition 2, check. Then finally, condition 3, does the two limit equal each other? So if I look at it, the limit of x approaches c is here. F of 1 is here. They does equal each other. So therefore, this function is considered a continuous function. And that's the mathematical definition that defines whether it's a function continuous or not. To be continuous, it has to satisfy those 3 conditions. If it doesn't, that is not a continuous function at the value c that you are looking at. Okay, at the domain constant c, wherever that may be. Like in this case, it's 1. In this case, it is 2, wherever they give you. Okay, does that make sense? All right. So now that you have a better understanding of the definition of continuous function, we can then apply it to actual problems. Okay. So keep this example in mind. Review this video if you get lost. Look at the example and see how I check the 3 conditions, okay? So that you can practice it correctly, all right?